with solving systems not by subtraction, but in this case we're going to use something called substitution. So now in the end we can use either method, either subtraction, addition, or substitution, depending on how the equations set themselves up, and one will tend to be easier than the other. However, you could do every problem with substitution or every problem with addition and subtraction. So this solution involves substitution, and basically what we're going to do is we're going to do a like for like replacement. So in this case here we have this balance, 2x's is balancing 2y's and 4, and this balance is balancing 3 of the same x's plus 1, and we have 1x on this side and 4y's plus 7 on this side. So what we can do for substitution is we can isolate one of the variables, and then we can replace the like for like substitution. So it's going to look like this. So I'm going to take my equation and I'm going to get it equal to x. So I'm going to divide everything by 2, so I get x is equal to y plus 4. So we can take y plus 2. We take half of everything on this side. So we have 1y plus 2 is the same as 1x. And then what we do then is, once we have this x isolated, we're going to replace every one of these x's in the other equation, not the same equation, but the other equation. And we're going to replace that with y plus 2. So here's another x, and we're going to replace that with y plus 2. Okay, so wherever I see the brackets here, this is my x. This x here gets replaced with y plus 2. This x here gets replaced by y plus 2. And in doing that, what we've done is we've replaced every x in this equation with a y expression, which then eliminates all the x's. So we now have a situation where we have one variable, one equation. This can be solved. So I'm going to go ahead and expand these brackets. I'm going to combine like terms here. 5y plus 9. Okay, so we end up with 3y plus 7 is balancing 5y plus 9. I'm going to subtract 7 from both sides. Subtract, let's subtract 9 from both sides, because we're going to keep the y on this side. So subtract 3y, subtract 3y. My new balance then works out to be negative 2 equals 2y's. So I get my solution y equals negative 1. So we've solved for y. And the nice thing about this substitution method is we can then, when we substitute back into the other equation, actually it doesn't really matter which equation we plug it into, but it would make more sense to plug it into this one, because notice that we have all our x's spread out. We have x's spread out all over the place here, whereas here we have everything equal to x. So when I substitute for y, my x is an easy calculation. So I get y equals negative 1 plus 2, and then we get x is equal to positive 1. Okay, so there's my solution. So basically what we're doing is we're making the one equation equal to one of the variables, and we're going to substitute one of the variable in the other equation. We can't substitute into the same equation, it has to be the other equation. And what ends up happening is we end up eliminating a variable, and we just have an equation with one variable which can be solved in this case.